Hello guys, today I just want to continue on the last video we did with stocks and machine learning. So in the last video we only used volume and RSI data to predict the price movement of Tesla. In this video I'm going to use the S&P 500 index instead, and in this file I'm going to use RSI, Bollinger Bands, MACD, and every single data. So, and also I added a few more models to improve it. So these are the classification models, which is predicting the direction, next day's direction, which is 1 is going up, -1 is going down. And the regression models, these three, are predicting this column, which is how much it's going up or down by. So essentially like this one is going down by 0.28%, so it's going down, it's -1, and then we're gonna drop NA, and we have actually 8,500 features, and then these are all the features, and 2 types of labels, and we train them. So the classification models actually perform better than last time. It has accuracy of around 54.5%. And then regression models, since we can't actually use the accuracy score because you don't have the exact value, like it's not 1 or -1, we have to use something called R2 score. So if the R2 score is 1, then it's exactly correct prediction. If it's 0, then it's not far from the mean. If it's less than 0, then it's basically worse than the mean. So, and then same function from the last video to check the individual price. So on 2023 December 28th, on the 29th, the stock price goes down by 0.2% to 8%. And 2 out of 4 classification models predict it's going down. And our best model actually predicted it's going up. So, and then the regression models, again, 2 out of the 4 predicted it's gonna go down. Yeah. And then check the day before that. So on 28th, 27th, it's trying to predict the 28th. On 28th, it goes up by 0.037%. Again, these 2 models predict it's gonna go up, and then 2 out of 4 models predict it's gonna go down. So I guess the results are varying for this file. Also decided to use the macro and volatility data as well. So for this project, we're gonna predict the monthly stock price, and everything is basically the same, and when you plot it, it should look something like this. So the monthly data date back to 1875, but we don't have the macroeconomics data up until around 1990. And this is from 1990 to 2020. We have the crash of 2008 and also COVID, and some bearish periods on 2001 and 2002. So if we zoom in on 2008, we can see like all these indicators, and the legend is right here. So let me just alright, so essentially we're going to predict this part or this part, right before the crash, and we can right away see that the consumer sentiment is going down. So I guess that's a good indicator. Also, what is this? Treasury yield is also going down. Yeah, and unemployment not really good. It's kind of lagging. Inflation is definitely lagging. And CLI is supposed to be leading indicator, but it kind of happens with the crash. So yeah. Alright, so the data I'm using are composite leading indicator to detect recessions, DGO, durable goods order, to measure how much people are manufacturing and ordering, inflation data 5-year, consumer sentiment, unemployment data, volatility index VIX, and interest rates. These are treasury yield from the periods. And then we merge all of these into one big data frame, which includes dividends and earnings and price to earning ratio, and drop NA. So now we have 200 features we can train. And now for the technical indicators, we've got all of the indicators we did on this project. Yeah, this is the RSI one. Yeah, and this is when we plot with MACD signals. And Bollinger Bands. Well, I also wrote this, but it doesn't really help much. So the RSI function, if it's under 30, then it's over sold. Over 70, it's overbought. And merge, and then we have to merge the macro data and the technical data. So now we've got 29 columns, right? And we can use the correlation function to see the correlation. So we're trying to predict next month and next direction. So whichever columns have the highest correlation, we're going to use that. And then import all these scikit-learn libraries. So I'm using the same models I used for the last project, and the classification regression actually have a pretty good accuracy, 60% accuracy for quadratic discriminant analysis. And for the regression, it's also pretty good compared to this one. The lowest is like 0.7, the negative 0.79 R2 score. So on October 2010, we're trying to predict November 2010, which is going up by 2.3%. And 3 out of 4 classification models say it's going up, and 3 out of 4 regression models say it's going up. So I would say it is going up too. And then for September 2010, we're trying to predict October. It is going up again, 4.4%. And 2 out of 3 model classification model predicts it's going up, and 3 out of 4 models regression models predict it's going down. So I would say this is a much better improvement from just technical only. Wait, I want to see if it's I want to see just technical only. So let's see. Oops. Oh yeah. Alright, so just technical, we actually perform better on the monthly time frame, which has 64% accuracy, And then this is pretty good. So technical performs better on the monthly time frame. Let's check it. Yeah, it's definitely better. So it's going up by 4%. And yeah, okay, it's good. And then let's see, instead of just technical, let's see just macro and volatility. So just macro and volatility, maximum accuracy is 67%. So that means that the individual, like if you choose either technical or macro, it's gonna perform better than using both. And so this one going up, and yeah, so basically you will ideally you want to choose either macro, fundamental, or technical analysis, not both, because if you use both, then let's see, yeah, the highest accuracy we got from both is 60. And yeah, that's it. Thank you guys for watching. I'll see you in the next video.